Right now, as you sit reading these words, you are falling. Not toward the Earth, not around the sun. You are plummeting through the cosmic ocean at 600 kilometers every second. Faster than you can comprehend. Faster than light travels from the moon to your eyes. You, your home, your planet, your star, and the 300 billion suns that make up the Milky Way are all tumbling together through the darkness, drawn by a force so vast it governs the motion of 100,000 galaxies. You cannot see what pulls you. It hides behind a veil of dust and starlight, obscured by the very galaxy you inhabit. For billions of years it has been calling, and for billions of years we have been answering, falling towards something we cannot name, toward a place we may never reach. They call it the Great Attractor, and this is the story of the invisible hand that shapes our corner of the universe. To understand what pulls us, we must first understand where we are. Picture, if you will, the cosmic address of your existence. You live on a world orbiting an ordinary yellow star, one among 400 billion suns swirling in a grand spiral we call the Milky Way. This galaxy, a disk of light 120,000 light-years across, is itself just one member of a small gathering, the Local Group, a collection of more than 50 galaxies bound by gravity, stretching across 10 million light-years of space. But the Local Group is merely a suburb in a much larger metropolis. 65 million light-years from here lies the Virgo cluster, a dense urban center of more than 1,300 galaxies packed into a cosmic neighborhood. And beyond that, clusters merge into superclusters, vast archipelagos of matter separated by voids so empty, so devoid of light, that they dwarf anything the human mind evolved to comprehend. This is the cosmic web, a latticework of galaxies strung like dewdrops on invisible threads of dark matter, with immense voids between them. Gravity weaves this tapestry. Dark matter, 5 times more abundant than the matter we can see, provides the scaffolding. And somewhere in this grand architecture, certain regions become gravity wells so deep that entire superclusters flow toward them like water seeking the bottom of a valley. For most of cosmic history, we believed the universe to be expanding uniformly in all directions, each galaxy receding from every other as space itself stretched outward from the primordial fire of the Big Bang. This expansion was codified by Edwin Hubble in the 1920s. The farther a galaxy, the faster it appeared to recede. A simple, elegant universe governed by expansion and gravity. But in the 1970s, astronomers measuring the cosmic microwave background, the faint afterglow of the Big Bang itself, discovered something peculiar. This ancient light, which should be uniform in all directions, was not. It was slightly warmer on one side of the sky than the other. By less than 1/100th of a degree, yes, but the implication was staggering. The Milky Way was moving. Not just spinning on its axis, not merely orbiting within the Local Group. Our entire galactic neighborhood was streaming through space at 600 kilometers per second in the direction of the constellation Centaurus. Something out there, something massive beyond comprehension, was pulling. The hunt began in earnest in the late 1970s and early 1980s. A team of astronomers, later known affectionately as the Seven Samurai, began mapping the peculiar velocities of galaxies, the deviations from the smooth Hubble expansion. They combined redshift measurements, which show how fast galaxies move away from us due to cosmic expansion, with independent distance estimates using Cepheid variable stars, whose regular pulsations reveal their true brightness and thus their distance. What they found was extraordinary. Galaxies weren't just moving away from each other due to expansion. They were also moving sideways, streaming together like rivers converging toward the sea. And all those rivers, including our own Milky Way, were flowing in the same direction. In 1986, the anomaly was given coordinates. The Great Attractor lay somewhere between 150 and 250 million light-years away, in the direction of the southern constellations Triangulum Australe and Norma. Astronomers estimated its mass at 10 quadrillion times that of our Sun, 10 to the power of 16 solar masses. A concentration of matter so vast it could account for the peculiar motion of everything in our cosmic neighborhood. But there was a problem, a profound, frustrating problem that would haunt astronomers for decades. The Great Attractor sits in the zone of avoidance. This zone is not a place. It is a blindness, a 20-degree wide band across the sky where our own Milky Way obscures the cosmos beyond. 600 billion stars shine in our galaxy's plane, their light overwhelming the faint glow of distant galaxies. And between those stars swirl vast clouds of interstellar dust, particles of carbon and silicates just microns across, yet sufficient to absorb and scatter more than 90% of visible light passing through. In the densest regions toward the galactic center, this dust can block 30 magnitudes of light, reducing the apparent brightness of a galaxy by a factor of 1 trillion. To study the Great Attractor was to peer through a sandstorm at midnight, trying to see a landscape you knew existed, but could barely glimpse. Yet astronomers persisted. They turned to wavelengths that dust cannot block. Infrared light, with its longer wavelengths, slips through the veil more easily. NASA's Infrared Astronomical Satellite, launched in 1983, revealed 2 massive galaxy clusters within the Great Attractor region, Abell 3565 and Abell 3558. By the late 1990s, X-ray telescopes pierced deeper still, revealing the Norma cluster, a dense congregation of large, ancient galaxies, many colliding with their neighbors in slow-motion catastrophes that would last millions of years, radiating vast amounts of X-ray energy from gas heated to tens of millions of degrees. The Norma cluster appeared to be the heart of the Great Attractor, a downtown of sorts within a larger cosmic metropolis. But the picture would grow more complex still. In 2005, the clusters in the Zone of Avoidance project reported a startling revision. The Great Attractor's mass was only 1/10 what scientists had originally estimated. It was not the end point of our cosmic journey, but merely a waypoint. Observations revealed that the Milky Way and the Great Attractor itself were being pulled towards something even more massive, the Shapley supercluster, located 650 million light-years away, 4 times farther than the Great Attractor. The Shapley supercluster is the most massive known structure in our cosmic neighborhood, containing the equivalent of 10,000 Milky Ways, 40 times the mass of the Great Attractor region. It is a gravitational titan, and its pull extends across hundreds of millions of light-years, influencing the motion of everything in our region of space. Our cosmic journey, it seemed, was far from over. Then, in 2014, everything changed. Astronomer R. Brent Tully and his colleagues at the University of Hawaii had been mapping the flow of galaxies for years, charting their peculiar velocities with unprecedented precision. They analyzed the motions of 8,000 galaxies, looking not at where they were, but where they were going, tracing the rivers of galaxies back to their gravitational sources, like following streams to find watersheds. What they discovered redrew the map of our cosmic home. The Great Attractor, they realized, was not a thing. It was a place. Not a single massive object, but a gravitational focal point, the bottom of an immense valley in space-time where matter naturally collects. And this valley extended far beyond what anyone had imagined. Tully's team defined the boundaries of this region using a radical new approach. They mapped not high-density areas, but basins of attraction, regions where all galaxies flow toward a common center. They gave this basin a name that means immeasurable heaven in Hawaiian, Laniakea. The Laniakea supercluster stretches 500 million light-years across and contains 100,000 large galaxies with a combined mass of 100 million billion suns. It encompasses not just the Great Attractor, but the Virgo cluster, the Hydra Centaurus supercluster, and countless other structures, all flowing inward like water descending toward a valley floor. The Great Attractor region sits at the heart of Laniakea, the gravitational bottom of this cosmic watershed. And the Milky Way? We reside in Laniakea's outskirts, on the edge of this immense structure, like a house on a hillside overlooking a distant plain. Imagine standing on Earth and watching the flow of galaxies. If you could see them moving in real time, you would witness a cosmic migration unlike anything in human experience. Tens of thousands of galaxies, each containing hundreds of billions of stars, all streaming together through the darkness. Some flow along great filaments, cosmic highways of matter, connecting clusters like bridges between cities. Others tumble through voids, vast empty regions where almost nothing exists, pushed away from these underdense areas by what scientists now call dipole repellers, cosmic pressure zones that complement the pull of attractors. The discovery of Laniakea solved the mystery of the Great Attractor, but it also revealed something humbling. Laniakea itself may not be the final answer. Recent evidence suggests that Laniakea might be part of an even larger basin of attraction centered on the Shapley supercluster, a structure 10 times Laniakea's volume, spanning billions of light years. If this is true, our cosmic address becomes almost incomprehensibly vast. Right now, at this very moment, you are part of this grand flow. The Great Attractor pulls you toward it at 600 kilometers per second. In the time it takes you to draw a single breath, you have traveled 10,000 kilometers closer to the Norma cluster. Every 5 seconds, you traverse 3,000 kilometers, the width of a continent. Every day, 50 million kilometers. In 1 year, 18 billion kilometers, a distance that light takes nearly an entire day to cross. This has been happening since before the sun was born, before the earth cooled, before life emerged. For billions of years, this cosmic current has carried us, and for billions more, it will continue. But will we ever arrive? The answer is both yes and no, and it depends on a force that pulls in the opposite direction, not toward the Great Attractor, but away from everything. In 1998, astronomers studying distant supernovae made a discovery that shocked the scientific world. The universe's expansion was not slowing down, as gravity should dictate. It was accelerating. Some unknown energy, permeating every cubic centimeter of space, was pushing galaxies apart with ever-increasing strength. They called it dark energy, and it comprises roughly 70% of the universe's total energy. Dark energy and gravity are locked in a cosmic tug-of-war, and dark energy is winning. 9 billion years after the Big Bang, the universe's expansion began to accelerate. Since then, dark energy has been pulling space apart faster and faster. For now, on local scales, gravity still dominates. The Great Attractor's pull remains strong enough to draw nearby galaxies toward it, and this will continue for billions of years. Our local group will merge with the Virgo cluster. In approximately 4 billion years, the Milky Way and Andromeda will collide in a slow, majestic dance lasting billions of years, eventually forming a single elliptical galaxy, sometimes called Milkomeda. But on larger scales, dark energy is tearing the cosmic web apart. Superclusters like Laniakea are not gravitationally bound. They cannot hold themselves together against the expansion of space. Over tens of billions of years, the structures we see today will disperse. The Great Attractor will grow weaker as the galaxies it influences are pushed farther away. Eventually, dark energy will dominate completely, and instead of falling toward the Great Attractor, distant galaxies will recede from us at ever-increasing speeds. In the far future, hundreds of billions of years from now, The expansion will have carried distant galaxies beyond the cosmic event horizon. Their light will never reach us again. The only galaxies visible from Earth will be those in our immediate gravitational neighborhood, our merged local group. An observer in that distant epoch would see a universe that appears almost empty, with only a handful of nearby galaxies visible against an infinite darkness. The Great Attractor will have become unreachable, its influence reduced to memory, a ghost of the cosmic web that once was. But that future is unimaginably distant. For now, for billions of years to come, the Great Attractor continues its silent work, shaping the large-scale structure of the universe, pulling galaxies together, orchestrating the cosmic ballet that defines our corner of existence. There is something profound in knowing that we are falling. Not falling toward destruction, but falling through time and space as part of a dance that began at the birth of the universe. Every atom in your body was forged in stars that were themselves part of this great cosmic flow. You are made of matter that has been streaming through the universe for 13 billion years, pulled by gravity, shaped by dark matter, scattered by dark energy. The Great Attractor is more than a gravitational anomaly. It is a reminder that we are not still, not static, not separate from the cosmos. We are participants in a journey that spans scales beyond human comprehension, from the quantum fluctuations at the moment of the Big Bang to the vast basins of attraction that organize galaxies across billions of light years. We may never see the Great Attractor clearly. It may forever remain hidden behind the veil of our own galaxy, a presence known only by its effects, by the way it moves everything around it. And perhaps there is poetry in that, in knowing something exists not by seeing it, but by feeling its pull. As you drift towards sleep tonight, remember that you are in motion. You are falling through the universe at hundreds of kilometers per second, carried along with your world, your sun, your galaxy, toward a place you cannot see, but can measure, can map, can know through the language of mathematics and light. The Great Attractor awaits, patient and persistent, pulling you gently through the cosmic dark. And in its pull, you feel the architecture of the universe itself, the invisible scaffolding of dark matter, the relentless expansion of dark energy, the ancient choreography of gravity that binds everything together. You are home in the Laniakea supercluster. You are falling toward immeasurable heaven. And in this fall, there is peace. Safe travels through the cosmos.